Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in static. What is its title? Its title is equilibrium on two coplanar forces. Dear student, look at introduction about equilibrium. Equilibrium of parallel coplanar forces. Dear student, look at the first example. Uniform monod of length 1 meter and its weight is 50 Newton, acting on its midpoint. Take care, midpoint. Why midpoint? With uniform rod. Dear student, remember, a uniform rod means its weight in its midpoint. A uniform rod of length 1 meter and its weight is 50 Newton is suspended from its end by two vertical strings and carries two weights, one of which is 15 Newton from a point distant 20 centimeter from one end, and the other 20 Newton at a point 30 centimeter distant from the other end. Find the tension in each string. Remember, what is the required? Find the tension in each string. Solution. Dear student, look at, dear student, the opposite figure represents a rod or uniform rod. Its weight 50 Newton. Act on midpoint of AB. Remember, AB equals what? 100 centimeter or 1 meter. We have two tensions, T1, T2. Look at when r equals 0, therefore T1 plus T2, negative 15, negative 50, negative 20 equals 0. What you mean? Sum of T1 plus T2 equals sum of forces or weights of two forces 20 and 15 and weight 50 Newton. Therefore, we form the first equation, T1 plus T2 equals 85. After that, moment equals 0. Look at 20 times 30 plus 50 times 50 plus 15 times 80 equals T1 equal times 100. Moment about B equals 0. What you mean moment about B? T2 equals 0. Therefore, we multiply 20 times 30, the distance between 20 and B, plus 50 weight of the rod times 50 centimeter, plus 15, the second weight, times 80, distance between 15 Newton and B, equals T1 times 100. By simplify, dear student, find T1. After that, T1 equal 43 Newton. T1 equal 43 Newton. Substitution about T1. Therefore, T2 equals 85 minus T1. Therefore, T2 equals 85 minus 43 equals 42 Newton. We have two tension, T1 and T2. T1 equals what? 43 Newton. T2 equal 42 Newton. Remember, dear student, T1 plus T2 equals what? X and student, 85. When we add 15 plus 50 plus 20 equals also 85, this is equilibrium. Another example. Rod of length 120 centimeter and of negligible weight is suspended in horizontal position by means of two vertical strings at its end two weights of magnitude 5 and 8 Newton are suspended, and its point of intersection finds the tension in each strand. Remember, finds the tension in each strand. Solution. Dear student, we have AB is a rod, length 120 centimeter. We have two weight 5 and 8. We have two tensions T1, T2. By using equation of an equilibrium, T1 plus T2 equals 13, and we find moment about B equals 0. Therefore, we multiply 5 times 40 centimeter. 5 is weight, 40 distance between D and B, plus 8 times 80 equals T1 times 120. Dear student, in this case, we find moment about B to find the value of tension number 1 or T1. By using simplify, 12 T1 equal 20 plus 64 equal 84 divisible by 12, T1 equals 6 Newton. 7 Newton, 84 divided 12 equals 7 Newton. From 1 and we get T2 equal 6 Newton. Another example. AB is a uniform rod of length 1.5 meter or 150 centimeter. Remember, uniform rod. What do you mean, uniform rod? Yes, its weight in an end point of AB. AB is a uniform rod of length 1.5 meter and of weight is 140 Newton, acting on its midpoint. It is horizontal of two supports, one of the end A and the other one at a point C of the rod. If the magnitude of the reaction of the support at A is 2/3 the magnitude of the reaction of the support at C. Find the magnitude of the reaction at each support. This is number 1, distance between C and endpoint B. Solution. Dear student, let the reaction at C equal R, then support at the support, reaction at support A equal 2/3 R. And EC, let EC or support A, suppose EC equal X centimeter. Look at the opposite figure. AB equals 150 centimeter or 1.5 meter. This weight is active in midpoint, 140 at point E. The distance between E and C is X. Distance between A and E, 75 centimeter. Distance between C and B or CB length is 75 minus X centimeter. Remember, dear student, we have two reactions. The first is 2/3 the second. Let the first reaction is R, second reaction 2/3 R. AB is 150 centimeter, its length, E midpoint of AB. Remember, dear student, we form equation of an equilibrium. The equation 2/3 R plus R equal 140. To find the value of R, then 5/3 R equal 140. Multiply by 3/5 in each side. Therefore, R equal 84 Newton. After that, we find moment about A equals 0. Look at 140 times 75 negative r or minus r times distance between A and C is x plus 75 equals 0. Then 140 times 75 by substitution about r equal 84. Therefore 140 times 75 minus 84 multiply bracket contains x plus 75 equals 0. In this equation, find the value of x. 140 times 75 equals 84x plus 84 times 75. After that, we take 75 highest common factor. 75 times bracket contains 140 minus 84 equal 84x. Therefore, x equals 4,200 over 84 equal 50 centimeter. What you mean? 140, its nearest to point C as 50 centimeter. We say that support C at a distance 25 centimeter from the end B. Why? Because x equals what? 50. 75 minus 50 equals 25 centimeter. BC equals 75 minus x. 75 minus 50 equals what? 25 centimeter. Another example. Uniform rod of length 1 meter and of weight is 75 Newton. Rests in horizontal position on two supports. The distance between them is 24 centimeter. If the pressure on one support equals twice that of the other ones, what is required? Find the distance between each support and nearest end of the rod to it. In an equilibrium problem, we have two equations. The first equation, 2 in 2 equilibrium, R1 plus R2 equals sum of weight, or sum of reaction equals sum of weight. After that, we find moment about any point to find the unknown. After that, by substitution from 2 to 1 to find 2 support or 2 reaction. In general, in equilibrium, we have 2 equations. The first equation, we find 2 unknown, but the second equation, we use moment about any point to find unknown force. After that, by substitution from 2 to 1 to find the 2 unknown. Dear student, look at the solution of the previous example. Look at, dear student, uniform rod, it with 75 act at midpoint E. AB equals what? The distance between C and D, remember, 24 centimeter. We have 2 supports, C, D. The pressure in D have pressure on C, or the pressure on C twice pressure at D. Distance between C and D equals 24. Suppose or let CE as x, therefore ED is 24 minus x. By using equation of an equilibrium, therefore suppose EC equal x centimeter, therefore ED equal 24 minus x centimeter. Dear student, the first equation 3b equals 75. 2b plus b equals 75 means 3b equals 75, HB is 25 Newton. After that, we find moment about C equals 0. Therefore, B times distance between C and D is 24 equals 75 multiply x. Remember, B equals what? Excellent student. 3b equals 75b equals 15. 3b equals 75, b equals 25. By substitution about b equals 25, therefore x equals 25 times 24 over 75 equals 8 centimeter. What you mean? 2b, or the point C, is nearest to E with 8 centimeter. Or AC is a 50 minus 8. Why? Because AC equals 50 minus x. AC equals 50 minus 8 equals 42 centimeter. BD also is 26 plus x. By substitution about x equals 8, then BD equals 34 centimeter. Look at another example. Uniform rod of length 100 centimeter and of weight is 8 kilogram weight, suspended in horizontal position at 2 points. Each of them is at a distance 10 centimeter from one of its end by 2 vertical strings. The maximum tension in any of them is 16 kilogram weight. If weight W is suspended at a distance 20 centimeter from the midpoint of the rod, find W, which makes one of 2 strings about 2 cut, and then find the magnitude of the tension in the other string. Dear student, look at the solution. Very important example. Dear student, we have AB is uniform rod. What you mean uniform rod? Its weight act at midpoint E. What is the weight of AB? What is the weight of uniform rod is 8, act at midpoint E. We have 2 tension, T1 and T2. T1 and T2 act at 2 points is 10 centimeter from 2 ends. Look at T1 nearest to A with 10 centimeter. Also T2 or second tension is nearest to B with 10 centimeter. By using, remember, we have weight W act at point C nearest from E with 20 centimeter. Remember, the distance between E and C 20 centimeter. Distance between T1 and A 10 centimeter. Then the distance between T1 and point C is 20 centimeter. After that, we find the equation of an equilibrium. Then look at 16 T1 plus T2 equals W plus 8. T2 equals what? W minus 8. Therefore, we find moment about D. Look at 8 times 40 plus W times 60 equals or negative T1 times 80 equals 0. We form equation. The second equation, we have 2 unknown, but by substitution about 1 from 1 to 2, therefore 32 plus 6W minus 16 times 8 equals 0. 6W equals 128 minus 32 equals 96. W equals 16 kilogram weight. After that, T2 equals 16 minus 8 equals what? 8 kilogram weight. Look at another example. A beam of negligible weight and of length 120 centimeter rests in horizontal position on 2 supports at its two ends. At what points of the beam weight of 12 kilogram should suspend it so that the reaction at one end may be twice reaction at the other end. Look at the solution. Dear student, we have the beam. We find 2r plus r equals 12. There are 3r equal 12, r equals 4. After that, we find moment about A equals 0. Therefore, r times 120 minus x equals negative 12 times x equals 0. Therefore, we find the value of x equal 40 centimeter from the end A. 2r times x equal r times 120 minus x divided by r. Therefore, to find the value of x, 3x 120, x equals 40 centimeter from this point from the end A. Look at, dear student, another example. Uniform rod AB, weight of acting at its midpoint, y uniform rod of length 80 centimeter. If the rod is placed in horizontal position of two supports at its ends of the rod carries two weight. The first 5 Newton act at a point distant 60 centimeter from A, and the second 20 Newton at a point of distant 5 centimeter from point B. If the value of reaction at B is equal to double the reaction at A, find the weight of the rod and the values of reaction at A and B. Dear student, look at important solution. Look at, we have R1 plus 2R equals W plus 5 plus 20. The first equation, R plus 2R, negative W, negative 5, negative 20 equals 0. Therefore, we form equation has two unknown, 3R minus W equal 25. Therefore, the relation between W and R, W equals 3R minus 25. This first equation. About moment, about point A. Therefore, moment A equals 0. 2R, look at 2R times 80. What is 80? The distance between A and B equals 20 times 75 plus 5 times 60 plus W times 40. By using simplified divided by 20. Therefore, equation becomes 16R equals 180 plus 4 times bracket contains 3R minus 25. We form equation 16R equals 4R equals 80 or R equals 20 Newton. After that, by substitution R equal 20 in the first equation, we find the value of W. Therefore, W equal 30 times 20 minus 25 equals what? 35 Newton. We say that the reaction at support A equals R equal 20 Newton. And that at B equals 2R equal what? 40 Newton. By substitution, about R equals 20, 2 times 20 equals what? Equals 40 Newton. Another example. Bridge of length 30 meter and of weight 35 ton, weight acting at midpoint. List of two support at its end A and B. Dear student, we have bridge length 30 meter, weight 35 ton, weight acting at its midpoint rests on two support at its end A and B. If a car of weight 3 ton is moving on the bridge, find the pressure on each of the two supports when the car is at 10 meter distant from the point A. Dear student, this is very important example. Bridge has weight. This weight car is moving about the bridge at a distance 10 meter from one of two ends. This car is act on the bridge by its weight. The bridge also act on the car. Dear student, look at the solution of important example. Find also the distance between the car and the end A. When the pressure at A equals what? 9/10 of that at point B. Look at solution. We have a bridge. This bridge, its length 30 meter. A car at distance 10 meter. We have to support A and B, B1, B2. After that, we form equation B1 plus B2 equals what? 35 plus 3 equal 38 ton. After that, we find moment about A. Moment A equals 0. Therefore, look at 3 times 10 by negative plus negative 35 times 15 plus B2 times 30 equals 0. Therefore, 30 B2 equals 30 plus 525. We find the value of pressure to 18.5. After that, by substitution, B1 equals what? 19.5 ton. After that, 9/10, B plus B equal 38. By using simplify, B equals 20 ton weight. Moment about A equals 0. B times 30 equals 35 times 15 plus 3 times x. What is the value of x? 3x equal B times 30 minus 35 times 15 by using substitution about B. Therefore, 3x equal 20 times 30 minus 35 times 15 equals 75. Then x equals 25 meter. Then look at, dear student, a car at distance 25 meter from point A. The pressure of A equal 9/10 of the pressure at B. Therefore, a car at a distance 25 meter about point A. Dear student, by the end of the lesson, I am very happy to spend such time with you. Goodbye.